Okay, let's find the distance between these 2 points. To do that, I'm going to use the distance formula. D equals, okay, one big square root. Okay, we got to take the difference between the x-coordinates. I'm going to do it like this. I'm going to take -7 and subtract off 1. And you square that. Add that to the difference between the y-coordinates squared. So that's -5 minus -3. That's -5. It'll turn out to be +3 quantity squared. And then take the difference between the z-coordinates and square that. That'll be 2 minus a -4, 2 plus 4 quantity squared. Okay, so that turns out to be, what, 64 plus 4 plus 36, 104 underneath the radical. Okay, well that's going to be 4 times 26 underneath the radical. So we'll get 2 radical 26 if you simplify the square root of 104. Okay, so that's the distance. Now, let's say you want to find a sphere that contains these 2 points. So, okay, how do we do that? Well, we need to find the center of the sphere. And the center of the sphere, well, one way to do it would be to make it so the center of the sphere is the midpoint of these 2 points. So if we do that, the midpoint let's see, the midpoint is going to equal, and I'll just average all the coordinates together. Okay, we're going to have -6 over 2. If we add the 1 plus -7 and divide by 2, we'll have -8 over 2 for the second coordinate of the midpoint, and we'll have -2 over 2 for the third component. So that gives us a midpoint of -3, -4, -1. And we know that the radius of our sphere will be half the distance. That'll be root 26. So an equation of the sphere that contains the 2 given points would be x plus 3 quantity squared, that's x minus a -3, plus x plus 4 quantity squared, plus that of course should be y, and then finally plus z plus 1 quantity squared equals root 26 squared, which is just 26. So there's an equation of the sphere that contains both of the given points.